The Slutsky equation is a fundamental concept in microeconomics that decomposes the total effect of a change in the price of a good on its quantity demanded into two separate effects: the substitution effect and the income effect. Mathematically, for a change in the price of good $I, denoted as $P_I$, the Slutsky equation is typically expressed as where $frac partial x_ip W partial P_J is the total effect of a change in the price of good $J on the demand for good $I, Marshallian demand. $frac partial H_IPU partial P_J is the substitution effect, representing the change in the demand for good $I due to the change in the relative price of good $J, holding the consumer's utility $U constant. Hicksian demand. $X_J is the initial quantity demanded of good $J. $frac partial x_ip $rel is the income effect, representing the change in the demand for good $I due to the change in the consumer's wealth or income, $W, holding prices, $P constant. Mathematical derivation of the Slutsky equation. One way to derive the Slutsky equation starts from the relationship between Marshallian and Hicksian demand functions. The Hicksian demand $H_IPU gives the quantity of good $I that a consumer will demand to achieve a certain level of utility $U at given prices $P while minimizing expenditure. The Marshallian demand $X_IPW gives the quantity of good $I that a consumer will demand at given prices $P and wealth $W while maximizing utility. Consider a situation where the consumer is initially at an optimal consumption bundle $X of P_0, W$0 achieving utility level $U$0. Now let the price of good $J change to $P_J$1. To isolate the substitution effect, we hypothetically compensate the consumer with enough income $W$1 such that they can still afford their original bundle at the new prices. This means the substitution effect is the change in demand as we move from the initial bundle $X_IP$0 W$0 to the compensated bundle $H_IP$1 U$0. The total change in demand is the movement from $X_IP$0 W$0 to the new utility maximizing bundle $X_IP$1 W$0 at the new prices and the original income. The income effect then accounts for the change in demand as we move from the hypothetical compensated income $W$1 back to the original income $W$0 at the new prices $P$1, leading to the final consumption bundle $X_IP$1 W$0. Using calculus and total differentiation on the identity $X_I of P of PU equals H_I of PU where $E of PU is the expenditure function, we can arrive at the Slutsky equation shown above. The detailed steps involve differentiating this identity with respect to $P_J and using Shepard's lemma, $frac partial EPU, partial P_J equals H_J PU, and the relationship between Hicksian and Marshallian demands at the initial point, $H_JPU equals X_JPW, when $U is the utility from consuming $X at prices $P and income $W. Intuitive interpretation in economics. The Slutsky equation provides a powerful way to understand how consumers react to price changes by breaking down their response into two distinct motivations. 1. Substitution effect. This part captures the change in the quantity demanded of a good due solely to the change in its relative price compared to other goods. When the price of a good increases, it becomes relatively more expensive. Consumers tend to substitute away from this now more expensive good towards other relatively cheaper alternatives, keeping their level of satisfaction, utility, constant. This effect always moves in the opposite direction of the price change. If the price goes up, the quantity demanded due to the substitution effect goes down, and vice versa. 2. Income effect. This part captures the change in the quantity demanded of a good due to the change in the consumer's purchasing power, real income, resulting from the price change. When the price of a good decreases, the consumer has more real income, because their money income can now buy more goods. For a normal good, this increase in purchasing power leads to an increase in the quantity demanded. For an inferior good, an increase in purchasing power leads to a decrease in the quantity demanded, as consumers switch to more preferred goods. The income effect can either reinforce or counteract the substitution effect, depending on whether the good is normal or inferior. In summary, the Slutsky equation helps economists analyze consumer behavior more deeply by separating the impact of changing relative prices from the impact of changes in purchasing power on consumer demand. This decomposition is crucial for understanding the price elasticity of demand, the nature of different types of goods, normal, inferior, given, and for welfare analysis of price changes.